The velocity curve of a particle is given. We need to draw the displacement graph and also tell when the displacement starts to decrease. So if we look at the velocity curve here, it says that it starts from origin, the particle. The velocity is initially 0 and it starts from origin as well. So this one is the velocity given in foot per second, and it can be seen that the velocity reaches a maximum value at b, which is 4 second, and then the velocity starts to decrease up to c, and then at c it becomes 0. It changes direction and it goes in the negative direction. So the velocity is increasing up to there in the negative direction. At point D, which is 6 second, the velocity becomes constant there, like that. So when the displacement starts to decrease, it is obvious that the velocity is in one direction initially. From, if this is O, from O to A, this is increasing. Up to B, the velocity is increasing. After that, the velocity from B to C, the velocity starts to decrease. At C it is 0. So up to C, the particle is going in one direction with varying velocity. From B to C, the velocity is decreased, but it's still going in the same direction. So up to C, the displacement is increasing in one direction, and at C the velocity becomes 0 and the particle turns back. So the displacement starts to decrease from C. So C is the point here, which is 5 second, is when the displacement starts to decrease. So t is equal to 5 second is when the displacement starts to decrease. And then about plotting the graph, the displacement graph. So I will just draw it qualitatively. So we can see that from 0 to A, the velocity is increasing, so the particle is also increasing there, the speed there, the displacement is increasing. And say this one is B. From B to D, from B to C, this portion here, the velocity is decreasing, so the displacement is increase will not be as much as before. So it will be a concave down, because we can also see that this is a straight line here and a negative slope straight line. So the integration of that, which is the integration of velocity, is the displacement actually. So the integration of a negative slope straight line is a concave down parabola shape. So this is what it will happen from B to C. At C, the displacement will be maximum, and we can see from C to D, the displacement will start to decrease because the velocity has changed direction. It is now reversed, and it is still the same slope straight line, so it will keep the same concavity. It will be like that up to D there. So after D, what happens is the velocity is a constant value. It is negative in the same direction but a constant. So the integration of a constant is the negative constant is a negative slope straight line. So this will go like that from D. This is point D here, and from D to whatever, this one will, and at some point it will actually cross the origin. So the displacement will be 0, and then it will go in the negative direction because it is continuing in the same direction. There is no information about when it stops, so it will keep going like that. So yeah, that's about it. So basically, because of this straight line, the integration of that is giving this pattern here. If I draw with another color, this concave down, and from 0 to B, initially, if this is A, initially the increase of displacement will be bit higher because the velocity is increasing like that. But from A to B, it is increasing, but the increase is not as much, so this will have a slower increase. So this one, and from B, it is the velocity starts to decrease, and this shape are shapes, this shape is not a parabola, it's just a, so we can just draw it qualitatively. We can't exactly say whether it's a, because the integration of this will be a higher order polynomial, so we can just draw it qualitatively, and that should be okay. So yeah.